Hi, I'm Sean Higgins, editor for spar3d.com and the Spar3D newsletter. I'm here at ILMF 2019 at the Emesent booth, where, as I understand it, you guys have a pretty interesting LiDAR payload for UAVs to talk about. I mean, quick overview, what is it and what does it do?
Yeah, sure. So Hovermap is, like you said, a LiDAR payload for drones. What's unique about it is it's not just a passive mapping payload, it's actually actively using LiDAR data in real time to provide autonomy to the drone. So it's connected to the autopilot. We use LiDAR data to detect obstacles around the drone in a spherical field of view. So we're rotating the LiDAR to give us this full spherical field of view. Keeps the drone safe. Imagine like a safety bubble around the drone. If you're operating it, won't let you get close to structures, and provides mapping while flying without using GPS. So it's a SLAM-based system, which means we can go and fly indoors, underground, underneath bridges to map and inspect these areas. And the flight can also be GPS denied. So you can fly safely, comfortably under these structures where there's no GPS to map and inspect them.
So it seems like based on this, you should be able to send an autopiloted drone using the Hovermap payload, one, into a space where you wouldn't necessarily want to send a human surveyor, and two, be able to expect that the drone will find its way out and not crash into a wall somewhere or fall into a lake. Or do I understand that correctly?
Yeah, exactly. So that's the idea. I mean, there's many cases for underground mining, for example, where they need to capture valuable 3D data, and it's either just impossible to get into there because it's too dangerous, or the current methods of capturing these data, it's very challenging. It's dangerous for the surveyors to be there, so we can send in a drone to capture data that they've just never been able to capture before in terms of the level of detail and the point density, allowing them to generate new insights that they've never had for underground mining, and obviously many other use cases as well.
So what's the big challenge in developing a product like this? You know, as you describe it, you know, I've seen over the past however many years a lot of handheld SLAM-based LiDAR devices, but they've been a bit slower to come for the UAV market. I mean, what was preventing that from maturing?
I think it's been a combination of things. Obviously, to get something to work on a drone, there's size and weight constraints. So getting everything shrunk down into a package which is light enough to put on a drone, and you really need to process that data in real time. You don't have the luxury of collecting and then post-processing. If the drone is using the data in real time for navigation, it needs to have a SLAM solution in real time. So that's a big challenge. And then of course, there are many layers on top of that, like how to use that SLAM data to navigate. Problems which are common in robotics, we've had to sort of apply and put into the small package on the drone. Yeah.
So this is the payload right here. Yeah. And is this a Velodyne puck spinning on the front?
Yeah, so it's based around the Velodyne puck, the VL16 Lite. So all the typical characteristics of the puck we have. And then on board there's also an i7 class CPU which is processing the data. And load grade MEMS IMU. We don't need a high grade GPS INS system because it's a SLAM based mapping solution.
So I remember as we were discussing earlier, I talked to you about this, I think it was about 18 months ago. Yep. And so you were telling me this has essentially been in beta testing, or early adopter testing rather, since then. So it seems like it's probably been through a lot and proven itself in a number of applications already.
Yeah, definitely. We've had early adopters in Australia, Japan, China, Canada, and the US, testing it for a host of different applications. And they've been using it to map and inspect bridges, cell phone towers, underground mines, forestry, regular survey, and we've learned a lot from that. And now now that it's available commercially, we can use the learnings from our early adopter program to educate our customers where and how it should be used, what the value is in the data that we collect. So it's been valuable sort of feedback from us, and we've made sure that by the time we release it commercially, it's a rock solid product.